Welcome to SaitechLabs training division, my dear friends. In this technical series, I'll be explaining about the formulation of paints generally. You can take this technical series as paint formulation guidelines. So I will explain step by step so that kindly follow that. Let us take up the first step of this paint formulation guidelines. First of all, we have to define the product target. For instance, what kind of finish you are looking for, whether it is interior or exterior or enamel or primer or putty or textured finish or any other specialty coating. Then you have to check the gloss level, whether it is matte or semi-glossy or high glossy. You could have seen this eggshell finish. So that itself is called eggshell finish. It means it is between the matte and semi-glossy. So I would like to introduce this eggshell in between this matte semi-glossy. So now we have four types of glass levels: matte, eggshell, semi-glossy, and then high glossy. Some people they go even for dead matte. So that is a different case. So the next level is glass. Now let me go to the next stage, that is the chemistry behind that. What kind of resin you are going to use? That is the binder chemistry, I can say. So are you going to use the acrylic resin or vinyl acrylic resin or polyvinyl alcohol or polyvinyl acetate type of resins? Then styrene acrylic resin or a pure acrylic resin, alkyd resin, that is oil based resin, epoxy resin, then polyurethane resin. In fact, this resin can be classified into two types: thermoplastic resin, thermosetting resin. If you go for air drying, then you should go for definitely the thermoplastic resins. If it is forced dry, that is stowing type, then you have to choose the thermosetting type of resins only. And these are all based on the type of curing or type of drying, whether it is a that is a air drying or it is a kind of vapor evaporation type, like in the case of NC, nitrocellulose. Then whether it is a two-pack system or whether it is a forced drying system. So we need to classify this first of all so that we can have the correct choice of binder chemistry. That is the resin chemistry here. Then, as I already mentioned, the required film properties are very, very important. So, are you looking for any special kind of washability or a special hardness, flexibility, or hardness and flexibility both together? Then UV resistance, whether it is applicable for the roof or the external exposure, and are you looking for any waterproofing system? So let us be very, very that is confined about that. We have to define what is our requirement exactly. Okay. Now let us come to the second stage. We need to fix the PVC, that is pigment volume concentration. So we need to choose the PVC based on the product grade. For example, if you are looking for premium exterior acrylic emulsion, usually this ranges from 20 to 25 percentage. Then for interior washable, that is acrylic emulsion, usually it ranges from 22 to 30. Then for economy emulsions, it can be 35 to 45 percentage. For putty, 60 to 70 percentage. For enamels, it is less than 10%. So we have to decide the CPVC target, that is critical pigment volume concentration, and we must avoid exceeding that unless required for a specific purpose of porosity. Now, the pigment volume, how it is calculated? Let us do one by one. First of all, what is pigment volume? See, pigment is a powder. Extender is also a powder. Then we have got the solid part of resin. For example, when you use some alkyd resin, it may be of 50% or 55% or 60% solid. So we have to consider that solid part only. So this pigment volume concentration is nothing but, suppose let me take the finish where we don't take any extender. Let us have only pigments. So this pigment volume divided by pigment volume plus the varnish, that is solid varnish volume. That is very important. So into 100, and that gives you the pigment volume concentration. It means we know very well. For instance, that is density is nothing but mass by volume. That is weight by volume. Now we are interested to find out the volume. In that case, what we can do, bring this volume to the left side and uh, take this density to the denominator part so that it becomes what? That is, we have got the, we need volume. So weight by density. Listen to me once again. Weight by density. So that you are able to get the pigment volume. So we have got the pigment weight, say about 25 kg or 25 gram, let us say. So divided by, and its specific gravity. Suppose let it be titanium dioxide. So in that case, it would be around a 4.2 something. Let me say 4. And we are taking 24 gram of what do you call this titanium dioxide. So in that case, a pigment volume solid is, that is 24. That is the weight divided by the density 4. So 20 by 4 by 4, that is 6. So 6 is the volume solid of titanium dioxide that we are taken in our formula. Likewise, it should be calculated. Now, let us consider the pigment of, I mean, not pigment, the resin of solid content is 50%. So in the formula, we have got around 30 or 40 means, then 50% is 20 only because on solid. And its specificity, that is its density may be 1.0. So 1.02 something. So in that case, we had to consider the solid weight divided by density, and that is taken as the volume solid of the varnish. So from this, we are able to calculate the pigment volume concentration. So this is the way we have to proceed. So we have got a separate, in fact, I have introduced a calculator for this so that it should be very useful to you. Okay. Now let me explain to you how to calculate this pigment volume concentration and volume solids using this PVC and volume solids calculator. We can also calculate the pigment binder ratio. Now let me explain one by one. Let me take any product. For instance, in this case, I have got some yard drying enamel, ADE enamel white. Okay. So let us fill up this white paint. This is the product. And let us have our company's name like SaitechLabs, or you can put your that is company name. Then enter today's date. Then let us have the pigment here and titanium dioxide rutile I have taken. So here I have taken 12 gram, or if you want to have 15 gram, you can have 50 gram also. Then density. So the density of titanium dioxide rutile is 4.1. And then it is 100% non-volatile material. So you can mention the non-volatile content also being a powder. Let me say 100. Then you know very well, as I already suggested, That is, when you change the mass, it will change the volume also based on the density. As I already suggested, weight by density is equal to volume. For example, let me keep this 12. Instantly it changes 12 divided by 4.1, that is 2.927. So that is the volume of solids. We call it volume solid. Then extender. Calcium carbonate is an extender. So let me put 8 kg here so that now the density is 2.7 for calcium carbonate. And now it is 100% non-volatile. Okay, there is no volatile content. So it is 100% powder. And then now we can calculate the volume. 8 divided by the density is equal to 2.963. Suppose if you change this into 10, so it becomes a 3.704. So let me go back. So it is 8 kg. So 2.963 as the volume. And then binder. So we have got the binder, which is of long oil kit, say about 60% of non-volatile content. So I must definitely put this solid content, that is the non-volatile content, 60. Then what is the actual weight I have taken? 15. You know very well. Now, what is the actual weight we have taken in the formula? That is 60% of this 15. Are able to follow? So you have to consider that one. So 15 into 60 divided by 100. Okay. Then you can divide by the density of that particular alkyd is 1.05. You can divide it so that you are able to get how much? 8.571. Suppose if I put 20, okay, you can change the volume like this. So here I already taken 15. So let me go back to 15. Okay. Then we have got a mineral turpentine, and you need not worry about this mineral turpentine because it is not going to contribute in any way. Okay, so let us exclude this. Let us not worry about it because when we calculate the pigment volume concentration, don't worry about the additives and the solvents. You have to consider the two major ingredients. One is pigment, another is binder. Along with the pigment, you may be adding some extender in the case of primer, then you can include extender also. So you need to consider pigment, then extender, then binder. Now you just look at the formulas are given here. See, as I already told you, density is equal to mass by volume. So from this we have interchanged. Therefore, volume is equal to, you look at here, volume is equal to in liter mass divided by density. Are able to follow? So we are able to get it in liter. Then what about pigment volume concentration? 100 into the pigment volume divided by the total volume of pigment and binder solids. So that is why we are introduced to this one. So this is the PVC concentration. And what is the volume solids? Volume solid means 100 into pigment plus binder solids divided by pigment plus binder plus if there is any solvent, you can also include solvent. In the case of volume solids, it may be useful. Now, my point of view is to target on the PVC. So I'm very keen on PVC and the pigment binder ratio. So pigment binder ratio in this case, pigment volume divided by binder solids volume. That's all. So for everything, you need the volume solids. So we are calculating that aspect. Okay. Now let us check what is so this is the main, that is a pigment and a varnish. So here we are able to calculate the pigment volume concentration as what? 40.7. Do you understand this? And what about the volume solids here? The volume solids is 71.7. And what about the pigment binder ratio? It is a 0.7. And what is the total volume? This is 20.2. All these parameters are quickly calculated using this calculator developed by our SaitechLabs team. So, for example, let us try to play around this so that you will be able to understand the role of pigment and how they change the pigment volume concentration and thereby how the properties of the paint may vary. For instance, in this case, we have That is a 40.7 and a 71.7 here. Okay, let me change this. For instance, I'll put that is this. Let me remove this one. Okay, what will happen to this? You just look at it. The pigment volume concentration has come down. Are able to follow? Now let us introduce 8. It has gone up. So just by playing around the pigment and extender and the varnish, we can have different types of PVC. And that is why I suggested PVC is a very, very important parameter in deciding the expected quality of the paint. Okay. Let me explain more about this pigment volume concentration. You just look at this graphics. Here, I given low PVC and a high PVC. That is low pigment volume concentration and a high pigment volume concentration. So here, in the case of low pigment volume concentration, you can find a few solid particles representing the pigment or the extenders. Whereas you got the yellow binder matrix. Here, which is more exposed, binder is more exposed, right? The solid is less. So there is a less coverage, but you can expect better glossiness, better binding, better adhesion because the binder is more. So lower the pigment volume concentration, there will be more glossiness, right? But in the case of high pigment volume concentration, you can find more amount of pigment particles here and less amount of what that is the binder matrix. So the distance between the particles, that is pigment or extended particles, will be the least, and thereby you are able to get better coverage, but binding will be less. If it is too much, it may cause some porosity also. So you have to achieve the correct pigment volume concentration. And as I already suggested, you can classify the type of coating based on the pigment volume concentration. For example, in the case of automotive clear, you know very well in the case of clear, there is no pigment at all. Of course, let me put some ingredients, and because of that, it may have some particles here and there. So the PVC is less than 5% in the case of any automotive clear coat. But in the case of lower one, I mean interior matte wall paint, here it is exceeding 85 percentage. You can definitely note that that is the pigment particles and extended particles are more. The binder is less. If it is too much, definitely it may lead to chalking also. So you know very well it is dead matte, interior matte, and it is in between in the case of a high glossy and anti-corrosion primer. In the case of high glossy white top coat, you have got 25 to 65 and anti-corrosion 25 to 65. Okay, so in the case of high glossy white paint, it would be around 20 to 25. So likewise, glossiness, mattness, these are all dependent on the pigment volume concentration. Welcome to SaitechLabs training division, my dear friends. In this technical series, I'll be explaining about the formulation of paints generally. You can take this technical series as paint formulation guidelines. So I will explain step by step so that kindly follow that. Let us take up the first step of this paint formulation guidelines. First of all, we have to define the product target. For instance, what kind of finish you are looking for, whether it is interior or exterior or enamel or primer or putty or textured finish or any other specialty coating. Then you have to check the gloss level, whether it is matte or semi-glossy or high glossy.